3, 2, 1, go! Oh no! Whoa! And congratulations!
Outreach is communicating our scientific research to a broader audience. In QuSCo, we use traditional tools such as science fairs, lab tours, or presentations in high schools, but also something that's more recent, and that is the use of computer games to communicate science.
We had this small race with the lemons.
This was actually like a metaphor that I wanted to use, and then transitioning to actually what quantum control means.
We have two particular software sets that visualize quantum physics problems.
Quantum Moves is a game based on simulation of controlling atoms, and this game is a big part of my PhD. They're playing with actually one of the scientific levels. It's called splitting.
You can just play it without learning about the quantum physics that has motivated it, but if you get interested, then there's a lot more to explore.
I think games can be very powerful to visualize complex phenomena, and especially in quantum physics, because most of the quantum physics properties cannot be visualized from day-to-day life experiences.
So hello, glad you came. We will talk about quantum information processing. Not so much focus on the theory, but show you some experiments that may help to get a better intuitive understanding.
So we use different kind of props to give them a flavor of what quantum spin is.
If I switch on now the magnetic field, you see it's rotating. So Spindrops is a program that is designed to visualize the dynamics of quantum systems. We wrote a dedicated software which is extremely responsive. So with 30 frames per second, we can interactively, whenever you push a button or control something, it immediately responds. We can also visualize collapse of the wave function, and the world's kind of virtually split in different probabilities and different outcomes. If you play a little bit with Spindrops, you get a lot of intuition, and even if you think you're an expert, sometimes you get ideas that you would not have had without that visual context.
We gave an NMR Lab tour, and we gave them the feeling that how the experiment is done. And this is 600 megahertz. This is 800 megahertz. As an outsider, like if you look into a science lab, you get more excited because you have these instruments. So you think that, okay, these are real scientists.
Being able to communicate a highly technical subject in non-technical terms, that's a crucial skill that you will need whether you continue in academia or elsewhere. There's also techniques to be learned, and that was an important point in QuSCo, that we had a structured training program also on the outreach skills.
We organized outreach workshops for all the PhD students. In each of these workshops, we tried to introduce some new outreach ideas. For example, we helped them create posters for their research, and these posters, they could use it during a lab tour or during a science festival, and also for themselves creating like a portfolio that after they finish their PhD, they can use their portfolio later, even as like a job interview thing.
So if we look down along the z-axis, basically, we see these expected colors. It's important to really give the public a chance to get educated if they are willing to do so, and especially in these days when we had a lot of misinformation. It's difficult to distinguish what is real science and what is fake science, and I think the more contact people have with the actual scientists can only be beneficial for society.
Scientists are often considered as a very peculiar group of people, but we're not. And there are like lots of cool stuff we're doing, but it's not known to the society, and I think it's just very important that we speak for ourselves and kind of like advertise for it.